Here's an example real quick of rewrite trigonometric ones, okay? It's all about what we were talking about on that last one. What kind of manipulation do we choose to do? Now, I gave you 3 equations that you should have memorized. This, of course, from the unit circle. You can create multiple ones, okay? You could do 1 minus cosine squared is sine squared, okay? You could do 1 minus sine squared is cosine squared, and that's just moving it to the other side of the equal sign. You can also divide them all by sine squared or all by cosine squared, even all by tangent squared, okay? Which is a little weird, but still gives you manipulations of what you don't necessarily have to memorize, but that you can get from this. Cotangent squared, we don't know the integral, or we can use an identity with that by manipulating this to get cotangent squared right here. So if I divide by sine squared on each of these, you just created cotangent squared. And what you do to one side, you have to do to the other, right, of the equal sign. It's almost like a form of multiplying by 1, if you will. Okay, so you're doing that to everything, where this becomes 1 plus cotangent squared x is equal to cosecant squared x. Now, the goal is to get cotangent squared alone, so you're going to subtract. So where you used to see cotangent squared, you're now going to see cosecant squared minus 1. Okay, all I did was replace this per this identity by getting cotangent squared all alone. It's still from pi over 4 to pi over 2. It's still in respect to x, and now you can simplify. From there, you did all that work. Just make sure that you're careful with the distribution of that negative, because it's really going to be 2 plus 1 to give you 3. So 3 plus minus, not plus, 3 minus cosecant squared, and it is from pi over 4 to pi over 2. Now let me make some room, now that we used all this as far as our identity, because this is the way I want you to have it written on your paper. You'll have plenty of room to do this. The antiderivative is going to go immediately right after that, okay? It's still going to be from pi over 4 to pi over 2. What's the integral of 3? 3x. What's the integral of cosecant squared? So just cotangent by itself. If I said, what's the derivative of cotangent, what would you say? Negative cosecant squared. Because of this negative, be careful with that, it'll be a positive cotangent. Now you're just going to plug in your respective values so that you have 3 pi over 2 unit circle. Alright, so pi over 2, and there's 3 of them. So you're looking here. So what's the cotangent, otherwise the x over y relationship that you see right there at 3 pi over 2? Okay, well, what is that? You tell me. Oh, wait a minute. I went to 3 pi over 2, didn't I? Okay, so instead of 3 pi over 2, I needed to do what? Just pi over 2. So my mistake on that. So at pi over 2, what is the cotangent, otherwise the x over y relationship there? 0. So it'll be 0 over 1. And then you're going to subtract what it would be. Just pretend that it's going to go there. At pi over 4. So we have 3 pi over 4 is going to be adding, what's the cotangent at pi over 4? 1. Positive or negative? Positive. And the good shortcut on that is that's y is equal to x. That's a positive cotangent or tangent. And here that's y is equal to negative x. So we're going to have plus 1. So if I add all of this together, I have 3 pi over 2 minus parentheses the 3 pi over 4 plus 1. That's how you see this distribution of how they get the negative 1. And then the 3 pi over 2 minus 3 pi over 4 will give you a positive 3 pi over 4. Cool? Manipulation, rewrite, manipulation, rewrite. a lot of practice with these. Okay? I'm just trying to give you first go-tos, like a handful of go-tos that will help simplify stuff when you approach these, because they do get a little bit more difficult.